Welcome to this webinar about the industrial PhD student and industrial postdoc calls that will open soon. My name is Karl-Erik Orsén, and I'm one of the co-directors for WASP. And I will give this presentation together with Daniel Axehill and Mikael Norlöv and his PhD student, Bernhard Wult. So here you see the program: introduction, general presentation about the WASP Industrial PhD Student Program, general presentation about the Industrial Postdoc Program, and then Daniel will talk about the graduate school, and then Mikael Norlöv and Bernhard Wult will talk about perspectives from industry, and in this case it's ABB Robotics. And then afterwards we have a Q&A session. Okay. So WASP, Wallenberg AI Autonomous Systems and Software Program, Sweden's largest research program ever. It has 5 core universities: Chalmers, KTH, Linköping, Lund, Umeå. And then it has 3 affiliated groups of excellence at Örebro, Uppsala, and Luleå. The vision behind WASP is to do excellent research and obtain competence in AI, autonomous systems, and software for the benefit of Swedish society and industry. And the mission is to build a world-leading platform for academic research that interacts with leading companies and actors in Sweden to develop knowledge and competence for the future. Some numbers. The total budget is 6.5 billion Swedish kronor up until March 2032. And out of those 6.5, I believe it's 5.1 or something like that comes from the Knut and Alice Wallenberg Foundation. And the rest comes from universities and industries. And the goal is to get 600 graduated PhDs, but we will overshoot, so we will have probably 700 or something. And the second goal is to have around 80 faculty recruitments. So the overall goal behind WASP is to increase the competence level in Swedish industry and academia. And the way we do that is by producing PhDs that then mostly will go out to industry. And then in the universities, we recruit international faculty members in these areas. WASP is wide. Some believe that WASP is only AI. That is not correct. There is a lot of other stuff in WASP as well. Here are some of the research challenges. Complex data and models in AI. How do you combine neural network type models with physical models? How do you combine AI systems with humans in the loop? How do you provide explainability? How do you scale your systems? How do you distribute the resources? And then finally, of course, efficiency, verifiability, security, and robustness. WASP has a number of instruments. It has its research program. It has a graduate school where the PhD students are enrolled. We have recruitments of these international faculty. We have research arenas where the students get access to industrial lab scale systems where they can test their research ideas. We have internationalization, which I will come back to, and we have a lot of networking and events of different types. So right now we have 74 industrial recruitments. We have around 500 active PhDs. It's a bit difficult to get this number. Sometimes we say 550 and sometimes we say less than 500. But we know for sure that 187 have defended their thesis so far. And we have around 80 companies and agencies engaged in this. We have always, not always, but the last 3 years or so, we have said that we produce 1 PhD per week. But this year is the first year where this is actually true. So now we produce more than 1 PhD per week. And so it will continue for the coming years. WASP also collaborates with a lot of different other different Wallenberg initiatives. For instance, the Data-Driven Life Science Initiative, DDLS. We have collaborations with the Wallenberg Initiative on Material Science for Sustainability, WISE, and so on. And we have different connections with cybersecurity initiatives. The WASP research arenas I mentioned, the aim with these is to give the students access to industrial scale arenas where they can evaluate their results. And currently we have 4 of these, one on public safety run by Saab, one on media and language issues, a lot of focus on generative AI and so on. We have one on robotics run by ABB, and we will hear more about ABB later. And we have one on operational data run by Ericsson. And then we have another one currently being started called Medicine, WASP Medicine, run by AstraZeneca, which is a lot about drug discovery and pharmaceutical production. Internationalization, we have collaborations with the large prestigious universities. We have with Stanford, Aalto, Berkeley, MIT, NTU in Singapore, Caltech, ETH, and we also have with some British ones, which I didn't remember when I did the slide, so I just wrote ... We do annual study trips, so the students during their first 2 years can participate in one European study trip and one outside Europe study trip. So this fall there is one study trip to the Netherlands and one to Los Angeles. And then the students can also organize study trips on their own in the year 3, 4, and 5. So there is a cluster on robotics which are going to Japan in the end of the fall, I believe. Then we have the research stints, as we call them, that give the students the possibility to spend time abroad, either an entire semester or from 3 months and upwards. And then there is the postdoc program, so that the students that are finished can apply to do a postdoc at some of the universities that we have. We also have compute resources. We have the so-called Berzelius AI resource located in Linköping, which is an NVIDIA superpod. These numbers, I believe, are actually old. It has been updated since this slide was made. There is quite a lot of WASP projects that use this Berzelius resource. Okay, that was WASP very shortly. And now we focus in on the WASP Industrial PhD student program. So first the Industrial PhD and then afterwards the postdoc. So the WASP PhD student call. First, some general words about doing a PhD in Sweden. Nominally, it should take 4 years if you do the PhD at 100% level. That is seldomly the case. Normally, you do it at 80% level, and then it takes 5 years. The university PhD students, they spend 20% of their time doing teaching. And the industry PhD students, they typically spend 20% of their time working at the company doing tasks that are not related to their research. So 4 years, that correspond to 240 high school credits. And depending on where you are enrolled, depending on the department, you are required to take somewhere between 60 and 120 credits of courses. 60 courses, that is typically computer science departments. 120, that is typically mathematics departments, if I may generalize. But in most cases, I would say that it is 90 credits, and that corresponds to 1.5 years of full-time studies. And normally the different departments, they have some requirements on mandatory courses that should be part of this. And then WASP has requirements on 27 credits of mandatory courses that the students should take. And that means that out of those 90, typically, it's only 27 that are WASP courses. The other are courses that are given by the university or by the department or so on. And the rest, apart from the courses, that is the actual research and writing the PhD thesis. Okay, so WASP PhD students, they are employed by a company. They don't have to be employed when you apply, but they have to be employed when the project starts. And then they do their PhD studies at the university department of one of the WASP universities or one of the affiliated groups of excellence. And as I said, 4 years if you do it full time, and the normal case, 5 years, 80% time. And the company then receives 600K per year from WASP if they do it on full time, and 480K per year if they do it during 5 years. And that should then be used for partial coverage of the salary of the PhD student. This also includes a travel budget of 30K per year. And it's very important that even if you have a travel ban at your company, the PhD students should be allowed to travel to conferences and so on, because that's part of their education. And we enforce that. That's been enforced that in various ways. So if a company prevents a student, industrial PhD student, from traveling, then they won't get the 600K per year from WASP. And then the academic supervisor or advisor gets funding corresponding to 50% of the salary for the supervision, if it's done at full time. If it's done at 80% level, then it's only 12% of the salary during 5 years. And then the PhD student, he has 2 advisors, one university academic advisor and one industrial PhD advisor. Ideally, this should be a person with some research experience. He or she doesn't have to have a PhD, but it's of course an advantage, because then they know what the research is all about. And then the PhD student must spend at least 20% of the time physically at the university and at least 20% physically at the company. However, in practice, spending only 20% at the university is in most cases not enough. So I would say that one should spend at least 50% of the time at the university. And then there is a contract that is signed between the company and the university, but there is no contract between the company and WASP. So that is based solely on trust, I would say. Then the PhD student should have an individual development plan at the company that treats things like who is the main contact person, who is the industrial supervisor, what is the role of the closest manager, what is the role of this project in the overall company strategy. And then at the university, the industrial PhD student will have what's known as an individual study plan that details issues such as the time spent on research, research results obtained, and so on. But that is normal. That is what all PhD students have. Right now, we have more than 100 active industrial PhD students from around 80 companies. We have 33 industrial PhDs that are finished or done. Some companies have very large involvement in WASP. Ericsson has the largest number of industrial PhD students, but also Saab, Sensact, ABB, and AstraZeneca have several PhD students. But most of the companies, they have only one PhD student. Due to the rules of the foundation, it's not WASP, it's the Knut and Alice Wallenberg Foundation. Research institutes, for instance, RISE, and different public organizations, they may not participate in WASP. And it's not only the traditional systems-oriented industry that are part of it, but you essentially find companies in all branches like finance, media, consulting, health, and so on. You can find essentially everything in WASP. This call is for up to 15 projects. And you should note here that I say projects and not positions, and I will come back to that. The call opens the 9th of June, and it closes the 1st of October at 2 o'clock. The decision by the WASP board is communicated the 27th of November. The earliest start date is 1st of January, and the latest start date is 15th of June. And by the start date, the student has to be employed. Normally, the student is employed much, much earlier, but in some cases, they are not. But they have to be employed at the start date. And then you submitted through the WASP application portal, and this is actually the incorrect link I see here. It should say 25, I'm quite sure. So we change it. Okay, this should be the correct link. And you should use the application form available there. And this form should be signed by both the academic and the industry supervisor. So writing a application is nothing that the company can do on their own. It's nothing that the university can do on their own. It's a joint work, this application. 2 student projects. As I said, we have a call that is open for up to 15 projects. And the reason behind that is that you can actually apply either for a 1 PhD student project or for a 2 PhD student project. But you may only apply for a 2 PhD project if at least one of the 2 candidates is of the underrepresented gender. And by what underrepresented gender means is underrepresented on the WASP level. So that means the females, they are underrepresented. And this applies also if you are from a company where the males are underrepresented. It could be if you come from some medical company or something. But it's still female that this is for. If you have 2 female candidates, you should clearly describe the role of each of the students in the project and how they complement each other. And you should also think about this carefully, because a 2 PhD student project is either accepted fully or rejected fully. It cannot happen that only one of the 2 candidates is accepted. So let's say that you have one very good, extremely good candidate and one candidate that is on the borderline. Well, then you run the risk of having a reject for the full proposal. So you have to think through, you really have to have 2 very strong candidates if you should go for a 2 student project. And then each industrial supervisor may submit at most 1 application. A company can have many applications, but each industrial supervisor may have at most 1. I came to think about one thing. I think this only is for the current call. Maria, could it be that it also applies to old calls? Do you know that?
I'm sorry, say that again?
Yeah, let's say that you have an industrial supervisor that got the project accepted last year. Can the same industrial supervisor submit now? Yeah, yes. They can. Yeah. So it's only in this call that there is only a max of 1 per supervisor. Okay. So WASP then, what is WASP? Yeah, I assume that you know what WASP is already, but I have a couple of slides here. As you see, WASP is divided into 3 parts, essentially. It's autonomous systems, AI, and software. Autonomous systems, that is, it could be research on more general autonomy, but in most cases, it's actually research on the different enabling technologies for autonomous systems. And autonomous systems could be a lot of things. It could be transport systems, self-driving vehicles, and so on and so forth, but it doesn't have to be that at all. So some of the enabling technologies: perception, interaction, visualization, human-machine collaboration, multi-agent systems, robotics, cloud and networks, security, localization, optimization, etc., etc., etc. Most of the projects in the autonomous systems part of WASP, they have a strong systems focus. And they may use, of course, a lot of data-driven approaches, but also more classical model-based approaches. So it's important to have in mind that WASP is not only AI. It's not, I would say that it's roughly 50% AI only of the PhD students that finish. Then we have the AI part, also divided in two things. We have the so-called MLX part, which stands for machine learning, deep learning, and next generation / explainable learning. And then we have the math part, which is about the mathematical foundations of AI and machine learning, but also the theoretical computer science foundations of AI. And then we have software, both software methodology and software technology. And it should be software projects that somehow relate to autonomous systems or AI. So it could be projects where the software is used for the modeling or analysis or development, etc., of autonomous or AI systems. But it could also be software that internally contains or utilizes some technique from autonomy, automation, AI, learning, or feedback. Then we also have cybersecurity projects in WASP. And similar to the software project, they should be of relevance to autonomous systems, AI, and software. So it cannot be completely general cybersecurity projects. And right now, there is really no strong separation between these different projects, and especially not between the autonomous systems and the AI projects. But about 6 years ago, I just played around with word cloud. So I did a word cloud on what the autonomous systems and software students actually do. And this is the result. So it's autonomous and control and network and cloud and learning and decision and so on. And then I did the same thing for the AI students, well, model learning, deep networks, and so on. So there is a difference. If this had been done today, I'm quite sure that large language models and generative AI would have had large words in this word cloud. Okay, then you submit the projects, the proposals in the 1st of October, and then we evaluate them. And there are essentially 3 aspects of the proposal that are evaluated. It's the project, it's the PhD student, and it's the supervisors. So the project should have scientific excellence. There should be some element of uniqueness, visionary or novelty nature. It should be relevant to WASP. And it's good if there is some potential to collaborate with other WASP projects or other WASP initiatives, such as the VARAs. Then it should be the PhD student candidate or candidates if you have a 2-student project. And there it is mainly the grades from the master's education that one have a look upon. Because that is the only way that we really can evaluate the PhD students. We don't do any interviews or something at the WASP level. And then finally, it's the supervisors, both the industrial and the academic. We look upon the scientific merits, international research experience, pedagogical skills and merits, and shown ability and experience of collaborations between academia and industry. And then also doctoral student and supervisor constellations with underrepresented gender and or a good age distribution between the members are also encouraged. So they get a certain extra bonus during the evaluation. Okay. Then some more words. The industrial PhD student instrument, traditionally in Sweden, I mean, it's an old instrument. It has been around many, many years. And it is primarily aimed at students who already are employed at the company. They maybe have been working for 2, 3, 4, 5 years since they did their master's degree. But some companies, in particular small startup companies, they may have no internal candidate. In that case, it is also possible to employ a student candidate, especially for this position. But the candidate must be identified when you send in the application, but doesn't have to be employed until the start date. If you do this, identify a candidate, but doesn't employ him or her, then of course there is a risk that the student disappears after the proposal has been accepted, but before the start date. In that case, the company is allowed to propose a new candidate if that candidate has at least as good qualification as the original one. However, if the student decides to quit once the project has started, then the project will be terminated. Unless it's a very short time, yes, 1 or 2 weeks or something, a month or something, then one maybe can discuss whether they should be able to find another candidate. But it's nothing that goes automatically. If the student quits after a year or 2 years, then the money are lost. So how does a good proposal look like then? Well, it should, of course, fit into WASP. It shouldn't be outside the scope of WASP. There should be a clear and well-described scientific problem, typically stated in the form of a handful of research questions that should be answered in this project. There should be some novelty. I mean, you cannot come with exactly the same thing as what the last PhD student did. And then you should explain why the applicants are the best parties to address this problem. So why is it exactly you and this student and this supervisor that are best for solving this? And also how they complement each other. And then, of course, there should be some added value to the academia industry in Sweden. But I would say that the most important thing of all is that you have a strong PhD student candidate or candidates. That is the most important. If you have further information and questions, general questions, you can post to WASP Sweden. But if you have more local questions, you can contact one of the university representatives, and you see the list down there. And in the best of all cases, they can also help you to find an university contact person, a potential supervisor that fits into what you want to do. But in most cases, you already have these contacts. Okay. We are not at the questions and answer part here, but I still have some typical questions that I know will be asked. So how should a project topic be defined? I mean, what is the level? And of course, it should be sufficiently long-term so that the results still are of value to the company after 5 years when the PhD is there. And it should have sufficient research depth to allow for publications. Deviations, they typically happen. I mean, it's very seldom that the PhD students just follow a straight plan because things happen. And very few students end up with a thesis that is exactly about the problem that was initially formulated. It could be that the problem that was initially formulated becomes obsolete, or it's too difficult to solve, or it's too simple to solve, or something. So there are changes. And that is something which the company has to be aware of all the time. And then what is a good PhD student candidate? Well, an ideal PhD student candidate should have at least a couple of years of experience of the company, but still have the graduate education fresh in mind. He or she shouldn't have forgotten everything from university. But as I said before, WASP accepts industrial PhD student candidates also if they have shorter or longer experience. Then, of course, it's good if they have good analytic competence, if they are good at problem solving, and if they are good at both oral and written communication. And then finally, good grades, in particular in the courses of relevance for WASP and for the project. And what one should have in mind is that many of the WASP courses, they are rather mathematical in nature. So if you have a student which have barely passed the math courses in their exam, that's not a good sign, I would say. What is the objective for the company, for you? There can be many different objectives. One could be that you want to initiate a long-term collaboration with some strong research group in order to improve the company's innovation capacity. It could be that you have a very particular identified challenging problem that you want to have help solving. It could be just some general desire to increase the knowledge in some area that is of importance to the company. It could be that you have a very promising employee that you want to build up the competence for, give him something good, so to say. It can also be that you are looking for persons with sufficient skills to take a leading role in R&D after 5 years, and lots of different questions and objectives for the company. And then, of course, the company must be aware of the realities of PhD students. Around 1.5 years is spent on taking courses. Some of these courses may be of less interest to the company and even of less interest to the student. Still, they must be taken. An important part of the studies consists of travels to conferences, to summer schools, study trips, course meetings, in order to discuss and present and learn. And it's important that the students can participate in this. And as I said before, even if your company has a travel ban, the PhD students still must be able to travel. How should you guarantee that the PhD student and the results remains relevant to the company during this 5-year time period? Actually, it's almost 6 years because from the time you write the proposal till the project start, it's almost 1 year. So it's in normal cases, it's a 6-year process. One way of guaranteeing the relevance is to have a research-related shadow project at the company where you can take up intermediate results, evaluate them, and generate new research questions. And then you can also try to formalize the knowledge transfer from the university to the company by letting the PhD student give regular presentations at the company about what they are doing, what they have learned, and interesting things which they feel are of value to the company. And then another tricky issue. How can we be sure that the PhD stays with the company afterwards? Well, you cannot. But based on the statistics, most of them stay, I would say, but not all. Some even decide to go to academia. Some go to some other company. Some do a spin-off or startup and so on. And how do you start by involving you in this? Well, typically you start by identifying the PhD student candidate and the academic supervisor. And the university representatives can, in some cases, help you with the academic supervisor. So contact them if you don't have any contact yourself. And then start the project with discussions with the academic supervisor as early as possible, because the academic supervisor best knows which research problems that fit into WASP and which don't. There is actually a brochure that we did in the beginning of WASP, which discusses industrial PhD students more in general, PhD studies more in general. So you can always have a look upon that. I hope the link still works. Otherwise, you have to complain. Okay, so that was industrial PhD students, and now we have the industrial postdoc, and that is way shorter presentation. So the Industrial Postdoc Call, this is the third time we have this call. It targets newly graduated PhDs who haven't really decided if they want to go to academia or industry. And this is a way of doing a postdoc at the company, essentially. And this enables the company to get to know the postdoc and at the same time conduct a 2-year academic project. And it's the hosting company together with the university research group that applies, and they should be identified mentors at both the company and the university. No, we don't call them supervisor, we call them mentors here because it's a PhD that they should mentor. Industrial relevance and academic quality are the key priorities. The postdoc should be employed by the company, but the time should be shared between the company and the university, and nominally 50-50, but the rules now say that at least 50% of the time should be at the university and at least 20% of the time at the company. This is a bit strange because if you have a PhD postdoc candidate that have some experience of the company, then it's more important that that person spend time at the university. Similarly, if you have a postdoc candidate that has a lot of experience from university, then it's more important that they spend more time at the company. So that is something which you have to solve on a case-by-case basis. And then, although the main target is newly graduated PhDs, also candidates with an older PhD exam may apply. And the PhD doesn't have to be performed in WASP. It can be a PhD that is older than what WASP is, or that was done outside WASP, but still relevant to WASP. Because the projects, they are expected to address fundamental problems with industrial relevance within any of the WASP research areas. And the total grant over 2 years is 2.2 million, out of which 300K goes to the university and 1.9 million to the company for partial salary funding. SMEs, they get slightly more. They get a total grant of 2.7, out of which 2.4 goes to the company. And in this call, we have up to 5 positions here. And we don't have this 2-person project. It's 1 position we are talking about. Rules, yeah. For the project, at least 80% of full-time. You cannot do this on some half-time basis. At least 80% full-time, at least 50% of the time at the university, and the research should be at the level that it can be published in a scientific journal or conference. And this holds for the whole project, also the part that is performed at the company. And patent applications are not considered as scientific publications. The company should be sufficiently large to be a suitable host for the industrial postdoc, and we have interpreted that as that it should have at least 2 or 3 full-time employees, which is not much, of course. And there should be an academically competent mentor at the company working with research or research-related tasks. The industrial mentor should have sufficient academic competence, cannot be the same person as the university mentor, and the industrial supervisor or mentor should not have been the postdoc candidate's supervisor during his or her PhD. So it has to be a new person that is involved. For the university mentor, cannot be involved in the company, can be involved in the company, but not as the CEO. Can own parts of the company, but not be the main owner. For the industrial postdoc, he or she can be involved in the company, but not as the CEO. Can own parts of the company, but not be the main owner. If there are personal or business relationship between the applicants and the candidate, then you must be careful. It could be that we have missed some cases in the list above, which the Wallenberg Foundations still thinks are important. So if you have any of these issues, personal or business relationships, you should contact us before you start the process, just to check that it's okay. Then we have evaluation criteria, of course, the academic qualification of the industrial postdoc candidate, and this, of course, must be a PhD that this person has. The industrial relevance, scientific level, the qualifications of both the supervisors, as well as their potential to support the candidate and the project. Mobility, that's important. To what extent the candidate has changed research group between the most recent university appointment and the planned industrial postdoc. We actually had one case last year where it was a proposal, where it was a postdoc candidate that had done the PhD with the same supervisor that were supposed to be involved in the postdoc. And it was an industrial PhD, so it was the same company and the same industrial supervisor that was supposed to be the industrial mentor. And that application was rejected simply because of this. So mobility is important. It doesn't necessarily have to be physical mobility, that you move from one place in Sweden to another. That's not necessary, but you should definitely move from one research group to another or from one company to another. And then for work permit and resident reasons, it may be necessary for the applicant to submit the application prior to obtaining the PhD. In that case, there must be a statement from the PhD advisor attached to the application that clearly describes when the defense should be, the planned date for the defense. And this should be as detailed as possible. If the exact date is known, that's good. If the month is known, that's maybe okay. But if they only say the PhD will be defended in spring 26, that's not so good, I would say. Okay, more information, and it's the same persons here as you saw before. But also contact the WASP program office also, because some of the questions here are difficult also for the university representatives to answer, especially this that has to do with the strange relationships between the industry and the university and the candidate. So the call opens on the 9th of June. It has the same application deadline as the industrial PhD, and decisions communicated at the same time. Earliest start date is also the same, but the latest start date is slightly further on in time. And the reason for that is that it might take longer for the industrial postdoc candidate to finish current duties and tasks and so on. Okay, then we switch to the next part, and now we have Daniel Axehill. So now I will stop my screen and I will stop sharing, and then I'll leave the word to Daniel.
Thank you. And then I take over the screen here, the sharing. Hope you can see it. So thank you. So my name is Daniel Axehill. I come from Linköping University, and I'm a director of the WASP Graduate School. So that is what I'm going to talk about today, the WASP Graduate School. So the graduate school mission is to educate PhDs with skills in strategically important disciplines within WASP, and also give this person a broad knowledge of AI, autonomous systems, and software development. So these three directions are the core of WASP, as you probably know. So the WASP Graduate School is a pretty large, you can call it, organization. There are lots of people involved. If we take the students into account, there are currently 493 active PhD students. And there are about 100 industrial PhD students out of those. And 186 students have defended so far. the targets for 2031 are around 600 PhDs in total who have defended their thesis, and out of this, we expect 150 roughly to be industrial PhDs. So the goals for the students is that they should become knowledgeable researchers in these important areas of AI, autonomous systems, or software. The students should form a strong sense of belonging to WASP, connecting them together. In general, networking is very important within WASP. So you form a network for your future career, but also your more perhaps closer in time research, so you know who to ask about what in the future. And then students should get to know Swedish industry. This is also from different perspectives. So, I mean, industry is present, as you know, in WASP, but it's also present in for example, project courses and the VARAs. And also when we go to study visits abroad, then we also visit companies there. So students should also form a strong and valuable international academic industrial network. And here, of course, the study trips are a very important part for this, but there are also other ways of getting abroad. And to get this network, which is again valuable for different reasons, and very valuable also for the future beyond your time as a researcher within WASP. And then hopefully this should not even need to be mentioned, but students should strive for excellence there, because that's the idea with WASP, that people are really striving for excellence. So goals for the graduate school, this includes to organize courses and activities, and that is to provide students with state-of-the-art knowledge within these 3 core areas of WASP. We are organizing courses and activities then that take into account these needs of a heterogeneous group of students. They are spread out in Sweden, but they're also spread out in terms of interests and background. So this is a challenge in WASP, but this is also a benefit of WASP, that we can cross-fertilize between different people with different interests and so on. And it's also interesting to see different parts of Sweden. So we will also like to provide an added value to the students' PhD education, and you will soon see what activities that we provide. But many of these things are actually something which goes far beyond an ordinary PhD education. And we would like to provide opportunities to those that really would like to excel, and we hope everybody would like to do that. So then we get lots of work to give those opportunities. That's great. So this is the graduate school activities and what we call the general offer. These are the main core activities. One important such activity is the winter conference. So this is an annual conference where everyone in WASP meet, and is mandatory for PhD students. So the first year you get an introduction to WASP. So the idea here is to get to know WASP and other students. And then the years between the first year and the year when you have graduated, then you come to the winter conference and you give a poster presentation. The idea here is to network and to show other people what you're doing, so perhaps they know that it's you that they need to ask in the future or something like that, and you receive friendly feedback on your research. And then once you have graduated, it's time to come to the winter conference again, but this time you get a diploma, and we will celebrate your accomplishments. Then another important activity is the summer schools. We have different types of it. In particular, we have something which we call the community building summer school. This is basically how it sounds. So this relates to networking and building a community, and also to get to know WASP and other students. So this is mandatory the first year in WASP, and exactly what that means depends on when during that year you begin. Sometimes this common event in WASP is the winter conference, and sometimes it is the community building summer school. Then the second year you get invited to a thematic summer school, and the thematic summer schools, the idea here is to be more technical, to give you the opportunity to learn from experts. But again, also here, networking is an important part. But of course, the main thing is to get new technical knowledge. And this is also possible to join for year 3 and on. But the difference is that the second year you get invited to this, and year 3 and on it is optional. So you need to apply for it yourself, more drive this yourself. And then we have the international study trips. Each students, they are offered 2 centrally arranged trips and then 2 student arranged trips or cluster arranged trips, depending on how you would like. So these are very popular. So we basically go all around the world. And the idea here is to get new knowledge and again, to build up this international network. So the first year you are invited to one trip, and the second year you're invited to another one. And then year 3 and on, this is optional. And in principle, the first years you go to these centrally arranged ones, and then if you would like to, you can also do these more self-arranged trips later on. Then there is another opportunity to go abroad, and this is called the research stints. So it basically means that you can go abroad for 1 to 6 months and conduct research, and also here, of course, to build your network. So this is available from year 3 and on, and this is optional. But when we say optional here, you can also read it as recommended. I mean, it's all these activities are there for you because we think this is very valuable for you. But perhaps not everyone has time for everything. So, of course, one of the core activities or parts of the graduate school is the courses. And the courses, these are divided into 4 different categories. The first category is called the introductory courses, and these are voluntary, and you cannot include this in the required 27 HP. But this is basically to give you a good entrance to the graduate school. If you feel that, yeah, I would like to learn something more about, for example, introduction to logics for AI or mathematics for machine learning, you can take these courses. Then we have one mandatory course, and this is the ethics course. And then we have the foundational courses, which builds the foundation. And the idea with these courses is to give you a broad foundation to stand on, both in research, but also in your future career, independently of that, if that goes to industry or academia. So here you are required to take 2 out of 4, and you can select at most 1 out of AI and machine learning and math for ML. You can also formulate it in the way that you're required to take either autonomous systems or AI, let's say, and either autonomous systems or software engineering, cloud computing. I was confused by the order here. So yeah. And the idea here again is to give you breadth for the future, because we would like to give you a robust education. So you don't know what will happen in your career in the future. And then we have the advanced courses, and the requirement is to take at least 2 more courses beyond the courses that you already mentioned. And it's very natural, of course, to select then among these advanced courses. But it's also possible to select any of the potential remaining foundational courses. Yeah, so in total we have 18 courses right now that we offer. So the course schedule looks like this. I will not go into details, but roughly the idea here is that the introductory, the mandatory, and the foundational courses, these are given yearly. And they recur from year to year, with some courses scheduled for spring and some other for autumn. And then we have the advanced courses, and these are given, some of these courses are given odd years only, and some other courses are given even years only. So I think the take-home message here is to be aware of this and take a look at this when you plan your studies and write your ISP, so you know when to take what course. And then we come to the requirements. So, I mean, the WASP Graduate School offers a lot, and in principle, we don't want to require things, but still there are some things that we need to require for you to get a nice diploma in the end. And the mandatory activities, these are to take 27 ECTS credits of WASP Graduate School courses. Out of these 27 points, then 3 plus 12 ECTS credits come from mandatory and foundational courses. So here you have some freedom of choice, as I explained before. And then you have, in addition to that, 12 ECTS advanced and or foundational courses. And here you have full freedom of choice. So the idea with this 27 points requirement is that you should take sufficiently many courses of very important courses within the WASP areas. Then, as a PhD student, it is also mandatory to attend the annual winter conference. Don't think it shouldn't be you don't need to be forced to go there. It's a very nice event with very nice people and nice things happening and nice food and so on. So can really recommend that for everyone. Then we have also mandatory attendance at the community building summer school the first year, where you start to meet friends, and also we try to get you into WASP in general. And as I said before, depending on your starting date, your first event can be the winter conference or the community building summer school. If you also hear the abbreviation CBSS, that's the community building summer school. Then we have expected attendance for some activities, and this is regarding the 2 centrally arranged study trips and then the thematic summer school year 2. So expected can also be read as recommended. We expect that people are active in WASP, and I mean, the activities are there for you, so they are highly recommended. So with that, I would like to end and just to encourage you to take the opportunity that WASP is. It's a unique opportunity, and also strive to really do the most out of it. So thank you. And if you have any questions, I can take them if we have time for that. I think we have that.
I think there is a general question session after.
Okay. Then we take them later.
And I also seen that there are lots of questions in the chat, but we also wait with them until we have had ABB.
Then we do so. Then I stop sharing and you take over.
Yep. So, can you still see my slides?
Yes, we can see them.
Yes.
Okay, then we have perspectives from ABB Robotics. So, Mikael Norlöv and Bernhard Wult.
Yes, thank you. Can you hear me okay, Karl-Erik?
Yeah, we can.
Yeah, okay, good. So thank you for the invitation to be part of this presentation. I hope I can contribute together with Bernhard Wult, my colleague, and our industrial PhD student that will also give his perspective. Maybe we can say we together will emphasize on some of the things that we have heard from Karl-Erik and Daniel during this the presentations so far. So maybe you can just move to the next slide. Thank you. So ABB, just to give you very shortly, some overview of numbers. Karl-Erik showed the WASP numbers in the beginning. ABB is a global leader in electrification automation with more than 100,000 employees worldwide. Out of about 10% is in R&D and research. And we spend about $1 billion USD yearly in research and development. So you can move on to the next slide. The company is say, divided into different areas. So we have 4 business areas: electrification, low and medium voltage products, including chargers for electric vehicles. We have motion, supplying motors and drives for industry in general, covering a wide range of devices from low to high voltage and power motors. Then we have process automation, which is providing solutions for process control in industries like paper and metal. But we also have a branch which is going into marine technologies, and we are looking at control of boats or ships, but also marine automation for ports. So, which is actually similar to the next one, which is, I mean, in a sense, the robotics part. So I am together with Bernhard. We are representing the robotics and discrete automation. And we supply manufacturing industry with industrial robots, autonomous mobile robots now, and process control equipment, including drives and motors as well, but more for the manufacturing industry and not so much for the continuous industry like process automation. What we can say is that the robotics business is kind of in a critical point of development today. And I will come back to that related to the engagement in WASP and what the research areas related to WASP has an impact on our business overall. But you can move on to the next slide, Karl-Erik. So this is also one of these, say, group slides, but I brought it in here because I wanted to show the priorities and just show it to highlight some important components related to why we chose to engage in the industrial PhD program in WASP. I will say, I mean, the first bucket or the first part of this is related to the market leadership and technology. And they both goes kind of hand in hand for this. And we can say that, I mean, overall, we are moving towards providing more and more of services together with our hardware, because we come from being basically, I mean, very much an industrial supplier of robotics arms, if we look at the robotics business. And what we see is that hardware alone does not make us enough competitive on the market, because today price is getting more and more important factor. And what we can say is that the research within WASP and with the PhD students, we are able to explore new possible directions using, say, new technologies that are previously not been applied in the business. What we also can say is that we can cross-connect through WASP with other industries to see how autonomy and intelligence is developing in other specific areas in industry. And this is something which I think, I mean, it has been highlighted by Karl-Erik and also Daniel about the networking, and I will come back to that. The last thing here, which I think is the most important part of our engagement, is related to people. And I mean, that is really, I think, one of the obvious things, but it's still worth to emphasize. So whatever happens during the project, the employee or the colleague that has been, say, introduced into the project will be, say, working in the project, will come back to the company with extended knowledge, a large national as well as international network of contacts. And this is connecting back to the networking. And what I will also emphasize here is that it's important from the company to prepare before going into the project, so that these employees, student can spend time doing the research and not spend time in, say, critical development projects within the company. Because this is kind of, and I think Karl-Erik, you emphasized that quite a lot as well. That I mean, it's time 20% thought of spending into activities that are not directly research related in the company. So I mean, the 80% of the time should be spent on research. So this person that goes into this kind of project cannot be critical for customer-related issues or development. And this is going to be a major focus for this person during these 4 to 5, maybe even 6 years, and cannot be expected to deliver on other things in the company. For the supervisor, I mean, that goes into this, it is important to have a dialogue with a colleague student throughout the project to also make sure that the balance here is right. Because you as a supervisor may not be able to see everything that is happening around this person. So just to really make sure that it's not coming in, say, requests from other parts of the company to do developments or help with things that are critical. And of course, as your role is also to look at and make sure that the direction in the work is following the company's long-term roadmap. And that I think is also one of the things that is worth to really stress. Let the student have some freedom to explore, because going in one direction, which is exactly the one that the company is having today, that is probably not going to generate the revolutions in your business. So I mean, for us, it's also an opportunity here to explore, to be curious, and to look into new directions, new things that we didn't think about doing before. So curiosity is really important. You can move on to the next one, Karl-Erik. This is a slide from the International Federation of Robotics, and this is to show and motivate, say, why we are so interested in WASP and the research which is going on overall in the program. Within the robotics area, AI and humanoids have been on the agenda for quite some time now, but I think we can say that this is kind of explosion. There's an explosion in this area right now. And if you look at this picture, there is no surprise that they looks like this, and you see them included in the major trends for 2025. And if we look at what we have as research going on in WASP right now, we have 2 PhD students, and they are basically addressing number 1 here with physical analytic and generative AI, kind of also looking into sustainability and energy consumption as part of, say, providing services for doing things more efficient. And also number 4 comes as a result, looking into new fields of business and customer segments for us. And also, I would say, number 5 is kind of as a result indirectly. We are looking at using components of AI like LLMs, but also analytical AI to make programming, deployment, and use of robots easier, faster, and more energy efficient. And this is, I mean, this is really in line with our needs for the future, but also really in line with what is happening within WASP. So, say, rounding off from my side, you can move on to the next slide. My, say, takeaways. So why do we engage in WASP, and what are the, say, main things that we appreciate from our side? I can also say that I have myself been involved now as industrial supervisor in 2 projects. I have been a bit more involved, but not really as an industrial supervisor in another project. So we have 3. And then we have had 2 early projects from the beginning of WASP, where I was more remotely connected in those programs. So overall, we have had now 5 PhD students. And looking at the results, Karl-Erik touched upon that. I mean, what could you expect as a company from the output of these projects, and also related to the people's question, kind of. For us, of the 5 PhD students that we've had, we can say that 3 of them are now within the company, 2 have left, 1 didn't finish the PhD, 1 left for academia, and of the 3 ones that we now have, actually 1 is leaving for a postdoc financed by WASP as well. So I think this is kind of leaving the company. It's not an industrial postdoc, it's an academic postdoc, but doing it, which is it's a great thing, I would say, for WASP, and it's a great thing for the company as well, because it means establishing connections to one of the major, say, connected universities within the program. So, but I think this is something to take away as well. I mean, it doesn't mean that you will have to get the person back, but I think it's also about contributing to the both in the program, but also to the Swedish industry and the European industry and global industry as well, and academia. So the research team for WASP, I think, is really in the middle. As I've said, we are doing fundamental research in many other areas, like materials, traditional control, mechanics, and such things, but still the areas of WASP is super important for us. It's a long-term commitment, which is also very, very good and very much appreciated from industry, from our side. And then I would stress this about the networking. This connects national as well as international connections. So this is very, very good. The courses presented by Daniel, I think this is also very much appreciated from us, getting this broad knowledge, but also going into, say, specific areas within the different student projects. And then the research arenas, which makes it possible to connect both cross, say, universities, the different people working in the same area, but also other companies from our side, because it's a way to connect with, say, different related companies. Sometimes companies that we are not directly collaborating with otherwise. So it's actually a potential for us to find new partners through the WASP. So I think that is also something. Then finally, I mean, it's a great financial support. This is not to forget, because going into this kind of, say, development of people, if you do it financing only from the company, is quite, I mean, it's a substantial cost. So the support that we get, which is really great from WASP, is also a big plus. Then I should say also that, I mean, not all students need to be financed from WASP to be actually associated to WASP. And that is one of our PhD students actually got the financial support from the Strategiska Forskningsstiftelsen, but had a, say, associate connection to WASP as well, and could take the courses and be part of the program as well. So that is actually a possibility. Now, my short list, just before giving the words to Bernhard. Of course, find the right student. For us, it has been both actually employing students that we have had as master students, but in most cases, say, the student has been somebody that is already active in the organization. work out the best fit for hosting group and supervisor. This is something which I think is really, really important, because you are going to be collaborating with this team now over 4, 5, 6 years. But it's also a very big and good opportunity to be, say, collaborating closely with a research team in one of these universities in WASP. Then very important to be, say, motivating this work to the company. Make sure that the work is in line with the long-term roadmap, because long-term, it needs to be on the long term, because it's not something that will be delivered within the next years. So, I mean, it's 5, 10 years ahead. And do not expect to get products as output. You will get a lot of results, but do not expect products, because this is more about people development, technology development, and things that can go into products in a later stage. Sometimes it happens that it becomes a product as well, but I would not think that is what you should expect. Make sure that your organization is prepared to handle the financial support for the complete project. This is very important. Times is, for the companies, typically goes up and down. We have, Karl-Erik mentioned about the travel ban. This happens. But you have to be able, from the company side, to maintain this, because this is a commitment that you have to take for 4 or 5 years. So this is very, very important to have this established within the organization. And finally, again, emphasizing on the collaboration and networking. This is something which is great for the student going into this, but if you're involving in this as an industrial supervisor, this is also for you, I would say. I mean, there are so many interesting events, so many possibilities for networking and collaboration. So just use it. I mean, it's a fantastic opportunity. So with that, I would like to say good luck with the applications, and you can move on to next slide and give the word to Bernhard. Please, Bernhard.
Yes, thank you, Mikael. Can you all hear me?
Yes.
Yeah, so I'll just give some thoughts on my industrial PhD experience as a WASP student. So you can move over to next slide, please. Yeah, so short, just a background about me. I did my master's in mechanical engineering in Luleå. And then afterwards, I just started to work for ABB Robotics in Västerås, where I was working with mechanical design and software development. And then in 2021, I started my PhD program for WASP. And my hosting university is Uppsala University. And the topic is motion planning for robot arms. And to just get an idea of what that is, I kind of visualized the motion planning problem in the 2 plots here. So here you see a very simple robot arm, and its motion is swept from a start and goal position in a continuous fashion. So this is basically the motion planning problem, to find this continuous collision-free motion. All right, you can move over to next slide, please. All right, so why did I decide to do a PhD? Well, back then in 2017, AI was kind of a big thing. And I felt that I didn't get enough knowledge from the university about deep learning and all of this. And yeah, I was just very curious, and I wanted a deeper understanding of the underlying methods. And then why did I want an industrial PhD student or a PhD? I mean, it's mostly, I kind of felt that I was working with a very exciting product, and I just wanted to kind of advance more in my role, working for the company, more into becoming an expert. So that kind of motivated me becoming an industrial PhD student. Right, next slide, please. Yeah, just a note on the practical setup and just some thoughts about the experience so far. So my setup is currently that I have a 80-20 split between research and work. I think this works really well. It allows me to focus mostly on research, of course, which is very nice. And then I decided, I was living in Västerås back then, but I decided to move to Uppsala in order to come closer to the research group that I was working with. And it was also just much easier participating in courses and all the different events that are organized by the university. And yeah, like my experience being like an industrial PhD student, so my topic is very much grounded in industrial need, but it's already a very well explored topic. But yeah, we kind of wanted to take a deep learning approach to this. And I mean, it's very exploratory. And I feel kind of you have this entrepreneurial role where you kind of have to take something from theory and then apply it in practice and show that it really works and makes sense for the industry. So yeah, I would say this, you have like a very entrepreneurial role. Next slide, please. Okay, so benefits of being part of WASP. I think all of these topics has already been addressed, but I mean, I haven't really reflected on everything I participated in WASP. But now when I was giving the task to give this presentation, I was a bit like, yeah, then I kind of realized how much WASP has offered for me in hindsight. So first of all, WASP has like this graduate school, which you've been introduced to, and it gives you like a wide range of courses, so you can learn about AI and deep learning. And one of the great things with these courses, in my experience, has been that it has a lot of different participants from different universities. So it's kind of fun to get together and then, yeah, make new contacts and get to learn new people. And then like you have this winter conference, which is an annual conference. It's always been in Norrköping so far. But I think it's a great event because it's just like, first of all, it's impressive to see all the PhD students gather at one place. And then it's also easy to like get to know what everybody are doing and just make new contacts. So I think it's actually a very great event. And then you kind of meet everyone that you've got to know during the courses and whatever. And then a note about this Vara Robotics Arena, which is kind of a platform that is provided by or hosted by ABB Robotics. So that's a great platform if you want to do like practical experiments in your research. And I've had like a very good experience with this arena. So like the people there who took care of this, they really like listen to your needs and helps you get started with whatever you want to do. Next slide, please. All right, so yeah, moving over to the research trip. I went to Boston 2023 together with Carl Erik, actually, and yeah, many other students as well. So this was also a very like interesting visit to Boston. We visited a lot of different places. So for instance, MIT, Boston Dynamics, and it was just like very interesting to see kind of their perspective and what they're doing. And it also got me like the opportunity to reach out to research groups, which I had been following for quite some time. So that was also very nice. And then self-arranged study trip. So in 2024, me and some other people from other universities, we arranged like a self-arranged study trip to South Korea. So basically we compiled our own schedule. We reached out to different companies and universities, and then we like visit them. And that was also like very inspiring to see like what they're doing and what they're focusing on over there. And yeah, the final point here is research stay at an external university. And that is what I'm doing currently. So right now I'm at ETH in Zurich. So I've been here for roughly 3 months, and WASP has made it really easy to apply for funding and also to reach out to ETH. And yeah, it's just been a great opportunity for me to focus on my research in a different area and start collaborating with like other peoples in this group. And also it's been very inspiring to be part of kind of this top research group. And yeah, here's a picture of me, which went away, but at least. Okay, so the final thing is that WASP has so much more to offer, which I have unfortunately not been participating in. But there are a lot of stuff that you can do. So like there are these clusters where it's like these self-organized groups in different domains. The summer schools, I haven't participated in those, but I mean, it's probably a good thing to participate in. And then you also have a lot of these varas. So if it makes sense for your research, you can like really apply it in different domains, which is interesting. And then it's supposed to be a very good project course as well in the graduate school. So I think my key message from this is that like WASP has so much to offer, and it gives you kind of this unique possibility to just enlarge your network outside of kind of your hosting university or your company. So I would really recommend that you really like jump into this and really take the opportunity to do the most of the experience. All right, that was everything that I wanted to mention. Thank you all for your attention.
Thank you, Bernard. So now we have the question and answer session.